Good morning, everyone. My name is Darwin B. Mapote, and I am from Bsamt 4-5. This is a video for our Supersonic. So, for our problem 1, here we have an unknown gas at a certain altitude has a pressure of 50,000 pascals, a density of 0.90 kg/m³, and a temperature of 250 K. For our A, he wants us to compute for the R, or specific gas constant. For our V, look for specific heat at constant volume and specific heat ratio. Use specific gas constant, R, and Cp equals 1005 J/kg/K. So first, let's put our required here. Let's put our required here. For our required, we need R, Cv, which is our specific heat at constant volume, and our specific heat ratio, which is K. So first, let's compute for the R. Let's compute for the R. Yeah. For R. Oh, sorry. Let's write our given first. Given. For our first given, we have pressure, which is 50,000 pascals. 50,000 pascals. Density which is equals to 0.90 kg/m³, and our temperature, which is 250 K. And for our B, we have a given of specific constant value for specific gas constant, which is 287.08 J/kg/K. Okay. And our Cp, which is 1005 J/kg/K. Sorry. J/kg/K. First, we have to look for our specific gas constant. So, since our base formula for pressure is P is equals to rho RT, we can derive the formula for our specific gas constant by dividing both sides by rho T. So we can have the we can cancel the rho T, and we can have the formula for R. So let's put it here. R is equals to P, which is pressure, then over density, and times temperature. So since we have our formula for R, let's put in the values, which is 50,000 pascals over density, which is 0.90 kg/m³. And for our temperature, we have 250 K. So let's solve. We have 50,000 over 0.90 times 250. So for our value of specific gas constant, we have 222.2222222. So let's just put the 4 decimal places. So 222.2222. And for our unit, we can have our dimensional analysis. So let's start over. For our pressure, we have PA over kg/m³ times K. So for our pascals, we can express the pascals into N/m². And next step, we can reciprocate it here, so we can cancel out the m². So m³ over kg And let's cancel this out, so we have nm over kg times k. So since we have nm times kgk, we can express this as joule. So for our final unit, for our specific gas constant, which is 222.2222 J kg K. So we have our first answer for the first required. So next we have our second required, which is CV. So CV, our formula for CV, we have Cp minus R, or specific gas constant. So let's put in the values. Cv is equals to 1005. We have 1005 J kgk minus 287.08 J kgk. So let's compute 1000 minus 287.08. So we have 712.9. So for our unit analysis, we don't have to cancel anything since it's subtraction. So we have our CV is equals to 712.92 J kg and K. Next, we need to solve for our K, which is specific heat ratio. And for our specific heat ratio, we can use the formula Cp over Cv. So let's put in the values. Equals Cv, since our Cv is 712.92 J kgk. And for our Cp, we have 1005 J kg K. So let's put in the calculator. We have 1005 over 712.92. So for our K, we have K is equals to 1.40 97. So for our unit for K, we can just cancel this out since they have the both units. So our specific heat ratio is unitless. So this is our final answers. We have our K, our CV, and lastly we have our R last, and that's it. Thank you. So for our next problem, we have a fighter jet is flying at an altitude of 12 km, where ambient temperature is 216.66 K. The jet's true airspeed is 650 meter second. Assume K is 1.4. R, or specific gas constant, is 287.08 J over kg. For our required, we have solve for A, or speed of sound, and Mach number. So first, let's put our required here. Required. For our required, we need A, which is speed of sound, and M. And also, let's put our given here. Given. For our given, we have a temperature of 16.66 K. We have a altitude of H is equals to 12 km. So the jet is flying at a isothermal layer. So the temperature is 216.66 K, since in isothermal layer temperature is constant. So lastly, for our R, we have 287.7.08 JkgK. So for our first, we need to solve for speed of sound, which is A. So for our formula, since we have K, we have R, and we have T, let's use the formula square root of K R T for our speed of sound. So let's put in the values. A is equals to square root of K, which is 1.4, and R, which is 287.08 JkgK, and our temperature, which is 216.66 K. So let's put it in the calculator. We have square root of 1.4 times 287.08 times 216.66. So for our value of A, we have 295.090.247 here. 295.090.2471. So for our unit analysis, let's set this aside. Wait. A is equals 295.090.2471. So for our unit analysis, since we are looking for the speed of sound, we need to get meter per second. So here, let us plug in the values. Since K is unitless, so we don't need to put it in. So for our R, we have J over K, G, K. And for our temperature, it is simply K. So let's just cancel it out. So we have J, K, and Kg left. So for our J, we can express it as Nm over Kg. So to express it further, we have N, which is N is equals to K, J, Kg, M. And since we have M here also, let's put in square here, over S squared. And since we have Kg left, let's put in here Kg, we can just cancel it out. And since we have a square to here, and we since the formula for speed of sound is square root of K RT, we need to square it out, then we can cancel it out. So we have meter squared. So here, for our speed of sound, we have 295.090.2471 meter per second. Lastly, for our Mach number, our formula for Mach number is V, or true airspeed, over A, which is speed of sound. So here, for our let's plug in the values. M is equals to, let's just store it as A. So V, we have 650 meter per second, and our A meter per second. We can just cancel it out since they have the same value. So for our Mach number, we have 650 over A. Over A. So for our Mach number, we have 2.2, sorry, T over A. For our Mach number, we have 2.2 something. Wait, let's just write it down. We have 2.202 7. Let's just cancel the 4 decimal. So for our Mach number, we have 2.2027. It's unitless since we canceled the ms or the meter per second. And for our speed of sound, we have 295.0902471. So that's it. Thank you for watching. Bye.